Hey everybody, in this video we are going to graph the example you see on the screen with the method I showed you 2 videos ago. So first thing I really want to do is I want to get this equation, which appears to be in what I would refer to as expanded form. I want to get this into factored form. You should recognize immediately that this is this is in expanded form, and it's the difference of 2 squares, so we will have x plus 4x minus 4 as my 2 distinct factors in the denominator. A little squished, sorry. So there we go, 1 over x plus 4 and x minus 4. So those are both raised to the invisible first power. That 1 is considered the multiplicity. Now let's go from here. For our x-intercepts, which are tied to my local behavior, can't have one without the other. Where are we going to look? The numerator of factored form. For my vertical asymptotes, which is linked with the asymptotic behavior, you're going to look at the denominator of the factored form. For the y-intercept, you're going to look at the constants, the ratio of the constants after you plug in 0 for x in the expanded form. And lastly, our end behavior, we're going to look at the leading terms. So everything's set up now, ready, set, let's go. So the x-intercept is not available. We do not have any. Like in the last example, 1 does not equal 0, there's no x, so you have no x-intercept. If you have no x-intercept, you have no local behavior. Next, vertical asymptote, we have 2. I have 1 at x equals -4 and 1 at x equals 4, 1 from each factor. Asymptotic behavior, they're both to the first power, so they both have opposite behavior on either side of the asymptote. The y-intercept is 0, -1 over 16, and my end behavior will have us looking at leading term over leading term, which is 1 over x squared, which means, similar to the last one, as x gets closer and closer and closer to infinity, right, as we approach it, 1 over x squared, if you aren't listening, my handwriting is pretty bad right there, becomes 1 over a bigger and bigger and bigger number, which means y equals 0 is essentially my end behavior. Okay, so at the ends of my graph, it's going to get closer and closer to 0. That's also on the video of the lesson, a breakdown where m is less than n. So go look for that in the box describing end behavior. So let's go ahead and put everything on here. So my y-intercept is -116. So it's right under the origin. Just really remember that. My vertical asymptotes are at -4 and +4. Yes, young man. What are you growling at? I gave you 2 options for dinner. Don't you growl at me. You think everybody's that lucky? I don't think so. You see him? Yeah, you can see him. He's being a little needy right now. But aren't we all? Horizontal, or really, it is horizontal in this case, not always. But my end behavior is y equals 0. And that's what I got. So what can I start? Now, if you notice, sometimes I don't really draw my asymptote, my horizontal end behavior, all the way through to the middle because it is end behavior. Okay? Now, there's my y-intercept. I cannot go through the x. I can't go up. I cannot. I don't have an x-intercept. So this is going to just kind of get close to the asymptote, and it's just going to have to ride down forever because it's going to have to keep going. All right? Let's actually give a little color here. I don't know if you could hear him if the mic's picking him up. So then, the same on this side, I'm going to go down, 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 because I cannot cross through the x-axis. So it's going to get closer and closer. Since the asymptote is opposite behavior, like this side has to be pointing up if the other side of this asymptote is pointing down. And then I'm just going to go out with my end behavior and get closer and closer to y equals 0. I really don't know if his... Yes, young man? Come here. Come here, show yourself. Come. Oh, thank you. Thanks, monkey. Okay. Then this, also pointing up since the other side's pointing down. And there you go. Beautiful. That's your graph. We could do our domain and range. So we can't really do our range. We can't do the range because we don't know. I mean, but you do kind of because, okay. Since this is an even function, which we talked about a few units ago, how to tell if something's even or odd. This is an even function, so it means it's symmetric over the y-axis. So it's pretty safe to say that negative 1/16 is the highest point of this hump. But more often than not, you're not going to be able to figure out how high or low little humps are without taking calculus or using a graphing utility. And in that case, you wouldn't do the range. But it's pretty safe to say that this little peak in the middle, it's probably going to be in the middle here, is at negative 1/16. So really we could do the range, but let's just focus first on the domain. So the domain is everything except, I mean, you could look at your factored form, right? With the x plus 4 and x minus 4, all right? So with those, we could see x can't equal 4 or negative 4. So domain is from negative infinity until negative 4. Parenthesis, because that doesn't include it, union, and then negative 4 till 4. Then I'm really struggling to fill this in. I don't know why I just wrote it here. And then from 4 until infinity. So hopefully you're listening to me so you could fix it nicely. So there's your domain, not my nicest. And then, like I said, the range, you could put, you know, can't do without a calculator, but really it's negative infinity until negative 1/16 with a bracket, union, parenthesis, 0 to infinity. I'm not going to write it. So I wouldn't make you do it unless you had a calculator or took calculus. And that's it for now. So we are following all of those same rules as before. This is what it looks like in these conditions, and I will be doing others shortly. Questions, comments, concerns, feedback, and requests, go in the comments. Check the playlist info in the thumbnail, or if that pops up, not the thumbnail, the click-through that comes at the end of the video, as well as the description box. Adios. Say bye, Dallas. Say bye. Say bye. I don't even care. No. Say bye. He doesn't. He hates it. He doesn't. He's not interested.